Hello guys, so I'm trying out a way to help you guys for Kirchoff rule. So first of all, I would like to share with you how to deal with Kirchoff rule, but bear in mind that this is actually my own way of solution Kirchoff rule. So if you are comfortable to follow this style, you may try to do this. So first of all, for Kirchoff rules, there are two rules that you need to fulfill, so do not skip. Please look for the two rules, and then actually the two rules will help each other. So for the first rule, we call it as junction rule. So we have it as the current in must equals to current out. So where the current ins, when the current flow, it will meet with one junction, and at that junction the current will divide into I1 equals to I2 plus I3. So you can make this as your first rule. For the second rule, which is called loop rule, so remember that loop can be choose between clockwise or counterclockwise. And the way to calculate for a loop rule, you have to use, for me, I always use all the batteries on the left and all the currents multiplied with the resistance on the right. For the function of these Kirchoff rules, it's only applied to DC circuit, and normally it is used to calculate for the value of currents when you have more than one battery connected in the circuit. So this question is taken from one of the lecture slides you have, so you can follow your lecture slides and refer to that. So for my way of calculation, first of all, I hope you can see it. There are two batteries, one 15 volt and the other one is 9 volt, and you can see that the direction is clearly stated there, where you can see this battery is pointing up and this battery is actually pointing to the left. How do I know? So you look at from the connection of the battery. So this is positive, this is negative, supposed to be. Okay, so my way of calculation is, for the first one, you choose the loop rule. So where do you want your loop to be? So here I choose this one to be clockwise, and this one will be counterclockwise. Alright, so from the first part, it is done. Then what you can do is you can write for the rules. For the first rule, it is always I1 equals to I2 plus I3. So name this as the first equation. And then for the loop rule, you can have for loop 1 equals to, refer to the first loop here. So what you can see is that this loop is clockwise, and then you only have one battery on this side, so that means this is 15 volts. So you only have one battery, then on the left it's only 15. So put it the equal sign, and then you can see that this current I flow together or with the same direction of the loop. So I1, because this resistance will have this current when this current is meeting back at this junction. So this is all I1. Then I1 will divide into I2 and I3. This whole thing is I3. This whole thing on the right is I2. So when they meet again, this becomes I1. So this you can write 100 I1. And then because it's the same as the loop direction, and then I3 is flowing down, the current the loop is also going down, then you put plus I3. So name this as your second equation. From loop 2, you can see that you have only one battery there, and I choose the loop to be counterclockwise. So again, one battery, that means the battery is the same direction with the loop, then it's positive. So later on, if you choose this as the other direction of the loop, then it becomes -9. For now, because I choose it to be the same direction with the loop, then it should be positive, equals to, you see here, your I2 is in the reverse direction of the loop. So this I2 should be negative, and I3 is the same direction of the loop, so I3 should be positive. So you can write it again. So you can name this as your I3. Okay, what comes after that is you have 3 equations with 3 unknowns. So to settle these unknowns, normally we use either substitution or elimination by mathematical approach. Substitution and elimination is actually subjective. So for me, I would use elimination more. Okay, it is less complicated for me. So what you can do next is you can set from inserting I on the first into second expression. What you can get is 15 equals to, then you change I1 equals to I2 plus I3. So what you can get is 15 equals to 100 I2 plus 200 I3. Okay, so next is you name this as number 4. Okay, so now you have only I2 and I3. Compare with number 3, you also have I2 and I3. Okay, sorry for that. So you have to solve for it. So you may write from 4 plus 3. So from 4 plus 3, you can see that you can eliminate I2. So you will get 24 equals to 300 I3. So please try, and then you will get I3 equals to 0.08 ampere. So you can substitute back, okay, for I3 from number 4. 15 is equals to I2 plus 200 I3. Then you will get I2 equals to negative 0.01 ampere. Okay, this is your second answer, first answer, and then you can go back for I1. I1 equals to I2 plus I3. Keep all the signs. Then you get I1 equals to 0.07. Don't forget the unit. So there you go.